Hi guys, and this video is going to be a bit shorter than the usual ones because the implementation of the merge sort is pretty easy compared to the hand ranker. So I thought that this time around I'd just do it live. I mean, who cares? I mean, the merge sort is like a double loop. Let me explain briefly what a merge sort is. In order to understand it, you need to understand the concept of merging two sorted lists. Suppose you have something like 2, 3, 5, and then in another list you have 2, 4, 6. The way the algorithm would work is that it would have like actually 4 different cases. It would go iteratively over both of the lists. It would have like 2 indices, something like I and I asterisk, and then on each index it would compare the two elements. It would start at something like 0, and then on the first iteration it would compare 1 and 2, and since 1 is less than 2 it would put 1 in the new array. Then on the next iteration it would compare 3 and 2. Before that it would increment the index of I. So it would compare 3 equals 2. Put 2 in the new array. Then it would compare 3 and 4. Since 3 is less than 4, it would put in 3. And so on. For example, another example would be something if you had like 1, 2, 5 and 3, 4. The way this would work is that it would compare 1 and 3. And since 1 is less than 3, it would put in 1. Then it would increment the counter for the first array, and then it would compare 2 and 3. Since 2 is less than 3, it would put in 2. Then it would increment the counter. Then it would compare 5 and 3. Since 3 is less than 5, it would put in 3. Then it would compare 5 and 4 and put the minimal element into the array, which is 4. Now the second array is all spent, so it would automatically put in what is left in the first array into the new one, which is 5, and so on. Let's move on to the code, and then it will be clearer. First, we have this merge sort function here in Spiral. We copy it because that's good practice. Who knows if in the future we'll change the SA, the static array type, so it uses references instead of values, and in that case this will become convenient. Let's start with the merge inner loop. In merge inner, it will have the left and the right arrays, and it will also have the counters, and I think that's all that we need. Now we just need to make a comparison for all the cases. For example, if I is less than length of the left array and I asterisk is less than length of the right array, let's do it length, and then let's do inp and inp asterisk, so we know what's what. And in fact, instead of having the arguments be like this, we can do inp I, inp, that's a bit better. Now we'll do a comparison. If index input, actually let's index into them first, left, right, index inp I, oops, it should be index inp. Now we'll do a comparison. If left is less than right, then actually let's make it let's make the left array the primary one, because the left array will be lower than the right. So we want to make this this kind of sorting for stability. If left is less than right, then we will return the left element. We'll also increment the left counter by 1 and return the right counter as it is. Else we'll return the right element and increment just the right counter. We don't have the array names properly here. Then in this case we'll just return the input. And in case that none of them are bigger than the other, we'll return I don't know. Yeah, in this case it should basically break out of the loop. This case should never occur. Let's do it error type, something like should not occur. Now why is this giving us type errors? Alright, instead of else this should be else if. Elif. Okay, we have the merge inner, and then we need the outer loop. Let's go back to Excalibur for a moment. The way what we've described, the merge sort with the inner loop, it will just work on when the arrays are ordered. I mean, if you look at here, 1 to 5 and 3, 4, they are ordered from the least to the highest. But in the real world, you'd of course get arrays like 6, 5, 9, 2, 1, something like that, in an arbitrary order. So the way merge sort works is that it partitions the arrays into the different segments, something like the way it does is that it has an outer loop, and that outer loop first sorts the arrays in the array segments individually. It starts with the array segments of the 2. For example, something like this. This is the circle. Okay, the singleton arrays it would return just as is. And what in these individual arrays, like 7 and 5, it would separate them out into 2 sets, like for example 7 and 5. Then it would sort them using that inner loop. Since we have just 2 elements, since we just have a single element in each of the 2 arrays, it's easy to see that the ordering property is met. So we just sort it like 5, 7. Then we also have the 9, 2 case. 9, 2. And then we also sort that as 2, 9. And in here we have 1 and nil. In here we just, in this case we just return 1. And we have a new array from this. 5, 7, 2, 9 and 1. We have this new array. Then we repeated the whole process from the top. And this time, instead of splitting the array into segments of 2, we instead split them into segments of 4 and the 1 at the end. This inner one we split into 2 again, into 2 halves, 5, 7, 2, 9. As you can see, these halves are ordered. Then we do the inner loop thing again. We have a 5, 7, 2, 9, and 2 is less than 5, so we put in 2, then 5 is less than 9, so we put in 5, then 7 is less than 9, so we put in 7, then the 9 is left over. And as you can see, these two arrays are perfectly ordered. And we also have the 1 and the nil, which results in an array of 1. Now we start the loop again. We have 2, 5, 7, 9, 1. Now we do the sort on the whole array. But in the very last iteration, we don't sort them into halves. Instead, we sort them into, we separate the two arrays into 2, 5, 7, 9, and 1. And we begin the iteration. We check whether the 1 is higher than 2, and it's not, so we put in the 1 first. And then, you know, the counter for the second array here is past the end. So we just keep returning the elements of the first array, 5, 7, 9. And this is how merge sort works. We just have to implement that in code. Okay, we have the inner loop sketched out. Now we'll do the outer loop. A regular loop wouldn't be good for us, so instead we'll something like, we'll have a midpoint. A midpoint will be 1. We don't need a counter in this outer loop. What we do have to check is that the midpoint is less than the length of the input array. Whoops, this is not F# but spiral, so we need the equals greater than sign for the lambda. Then we'll at the end of every loop here, we'll increase the midpoint by 2. And this alright, it should be in the loops folder, in the module, I mean loop module. We'll ignore the returned midpoint, because, you know, the statements, the expressions at that aren't at the function end or the if statement end need to be unit. It's the same way in F#, except F# would just give you a warning instead of an error. But in Spiral, I made it an error. Now, okay, let's do a single iteration of an inner loop. Just and instead of calling this the midpoint, it should just be something like the by. Let's buy. This should be the midpoint increment or something like that. And we'll make this the midpoint. Mid less than length of the input array. Fun mid. And this should be the mid. I mean, no, the by. And this should be the. Okay, we should start off this loop at by. Now what we'll do is calculate the loop segments. We'll do the from. We have the mid, and then we also need the near to. And the from is mid minus by. And near to is the plus by. What this does, let's go to Excalibur for a bit. For example, suppose we have something like 1, 2, 5, 7, 9. And what we need is something like a window that slides across the array. On the first iteration, we'll first process the 1 and 2, then 5 and 7, and then lastly 9. And the midpoint for this should be somewhere... Okay, the midpoint for this should be 1. That would make it 0 and 1, and this should be 1 and 2. This should be 2 and 3, and 3 and 4, the range for this. You'll see what I mean. Now we need another while loop, and this one should be fun, something like I is less than mid, or I is less than near to. These are actually this will be the conditional for this case here. It's similar to this. Now, fun. And this will be the from and by. No, from and mid, I mean, sorry. From and mid. Now, what we need to do is copy paste this here. I mean, copy it here, but we need to adapt it. We also need the output array. Okay, here's how we're going to do this. We should... okay, this is one of those subtle things. It should be actually an equals sign here. I mean, when you're working on a sorting function for the first time, it's easy to miss things like this. Then what we'll do is pass in a new array, something like no, we'll make an output array here, out, and it will be something like create. It will have the same dimensions as this. Then I mean, this isn't really a problem doing this like so, but you know, it kind of makes things confusing as to what the code should be. Just a second. Okay, let's ignore. No, let's make this actually less, because you know, if we get an array of size 1, we don't need to sort it. And ignore all these errors for now. What we'll do, the midpoint here should be increased by plus 2 in order to by times 2. All right, we shouldn't ignore. Oh, now why is this giving us a problem? Alright, we'll ignore this. Alright, it should be mid. Okay. Okay, now we have the two outer loops, and now we just need to do the inner loop, which is basically this. I'm just thinking about how we could do the output arrays succinctly. I can think of a few ways. For example, if these weren't value arrays but references, we could, keep swapping the input and the output arrays. For example, we first do a merge into the output, then we do a merge into the input, and so on, and then output the final array. Fine way of doing it, but these aren't references. So, okay, here's how we're going to do it in the easiest way possible. Inline out. We'll create a new array, and this should be like a copy of the input as well, maybe. Then we'll do a switch. Inline switch. And do something like true. We'll set this to true. Now we'll do two utility functions, something like index I, and then if switch, then index from the input with the I argument, otherwise index from the output with the I argument. And we'll also do a set. Then set output I to V. We'll also do value. Change. We'll keep toggling it. Toggle. Something like set switch, not switch. I don't need to put in these mutable setters into somewhere other than loop. But never mind. This is just the same as writing something like switch equals some kind of variable with a macro, except it's a bit more safe since it makes sure to push at this variable to runtime, just in case. Okay, now every time, in fact, we don't even need a switch. We can just pass it as an argument. And then this will be an optional thing. And in addition to the by, we'll do the switch. And then on every iteration we'll toggle it, not switch. Why is it complaining? Why is it complaining? I'll comment this out. Alright, it should also be in here as an argument. That is causing it. That is causing the state to be inferred improperly. It's a good feature of the type system. Okay, now we have the switching, we have the increasing of the by, then we have the index and the set. What we'll do is maybe just overload it. Index equals index switch, inline set equals set switch. We'll just partially apply them like this for ease of use. And this will not have any runtime effect. Now we can finally busy ourselves with the inner loop. And in fact, if switch, then out else imp. This is just a oh right. We need now we need to consider what the switch is. Fun switch. Now it will be right. Okay, now we can finally concern ourselves with the inner loop. We just return something like, yeah. I mean, this case is a bit annoying. If you are writing something like C and C++, you just use a break statement here, something like that. Or if you are writing functional code, you just not call the next loop iteration. But now we don't really have that option here, so we have to think about it for a bit. I mean, it's kind of like a design choice that we need to make. Also, with these two arrays, for example, instead of copying them like this, we could have just been swapping the references. If I was doing, if I was writing this function in F#, I'd do a Taylor recursive loop and just switch the arguments at every point. But unfortunately, the HLS C++ compiler doesn't support Taylor recursion or ordinary recursion, so that's not good. I mean, this is the correct conditional, but now if we do it like that, we don't really have the option of breaking out here. So what we'll do is just do an else styling here. I mean, this is the easiest way. We don't need to note which arrays we are indexing into explicitly. And then we'll bind the arguments, something like this. X set x, something like this. The period operators is the same thing as writing semicolon in F#. I opted for the period operator because it's easier to parse in records and arrays and list literals, for example. Now, why is this giving us trouble? Alright, no, wait. Just a second. Oh, this is a pretty weird error. That's something like less than mid. Then it has to be the other case, but now for some reason right. We need to pass in the for the set. We also need to pass in where it should be set. Okay, in that case, we won't return the we'll do it like set I. Alright, this is actually a good point by the type system. We need to actually keep a track of the counter for the output array. Something like it should also start from And it could be done using something like I mean, thanks to it, we don't even need to check these two separately. Instead, C, we'll do it as C less than near to, and then C, if I am mid, I less than near to, set, okay, set C al, and then C plus 1, set CR, C plus 1, set C, or right, we should be loading it here. Oh yeah, this is one of the, instead of index I, yeah, index I, oh right, set C index I, C plus 1, then set C index I asterisk C plus 1. Yeah, this is good. Now I should ignore. Alright, we should be using the provided function as a comparison, as a comparator. Let's do, okay, let's, instead of you know, comparing it like that, let's FLR with, we have this greater than and less than type, less than or equal, something like that. Okay, in that case, we'll start with greater than. If it's greater than, then we should do this, otherwise now we shouldn't be returning a tuple here. Instead of there should be separate statements. What is this? Okay, great. I think this is it basically. A lot of this out, and let's do something like inl x I, and then set C x I, now we can now that we have this, we can do some, we can factor it out like so. For example, we could right, we need to index into this case. And this needs to be a tuple, this as well. Oh, now we can be sure there are no errors. Okay, and I think this is basically the merge sort. Like, assuming there aren't any bugs, and we'll have to test to make sure that they aren't. We'll use the inbuilt C++ STL library function to compare it with. And besides that, I wanted to make to demonstrate something. In the previous video, I complained that the HLS community is incompetent due to not being able to make a merge sort function in a library, and I conjectured that this could be because it cannot pass in pragmas that way. So I'll show you how you can pass in pragmas. I'll change the name of this a little, and then pragma 1, pragma 2, pragma 3. Then for every loop, we'll just splice in the pragma. And we'll do something like pragma, and then HLS, and then we'll splice it in. All right, this should be done through the type system, actually, not through a string literal. Okay, let's do a little helper, so we can pass in the pragmas. In splice pragma. This should return a unit type. The X will be the pragma, and this should be a real function. Open real core. I mean, in the real segment, it will complain about getting a type error, even if you don't put in the annotation right there directly on it, even if it has an annotation on the other function. It cannot see it because this is the real segment. Now what we need to do is get the pragma at the type level, something like type case x fx. We'll implement the f later. Let's just pragma. Let's just bind it like this. Now we need the f, and what this f should do is take in a string and convert it to a symbol. And when the symbols get spliced using the at operator, they will get put into the macro as is, instead of with the quotes around them. That's why we need to first convert it to a symbol. In f, we need to convert it. I mean, we don't even need the f. We can just make it x, and then lit to symbol x. Let's just check the real library, real core. Where is the packages? Okay, here are the packages. We'll pin it using Ctrl Enter and Shift, using Ctrl K and Shift Enter. Then symbol. We have various testing functions. Symbol type is type to symbol, type lit to lit, lit to type lit. Type to symbol. I mean, do I not have anything in the library to convert a string to a symbol? It seems like I don't. Okay, we'll extend the language. And this is one of the great benefits of having your own language. If you don't have something in it and you need it, you can just put it in, no problem. Okay, we'll do that in the partial evaluator. We'll first search for the type to symbol. Okay, this just takes in a type and converts it to a symbol. It's a bit different. Let's do something like string to symbol, string literal, string lit to symbol. This won't be a type, but a regular expression. We'll evaluate it with the term. It just takes in a language environment and the raw expression and produces a data term. Delete lit string. Now all of this is green because this operation doesn't exist, so we'll add it to the language. Let's put it here, whatever. Or could we put it somewhere else? Oh, okay, let's put it in static unary operators. Oh, okay, not bad. Now the green should go away. It will take a few seconds for it to update the language server for AppSharp. Okay, now we'll publish it. Oh, this will take a while. Okay, let's save all this. We'll exit it. We'll load it in the VS Code plugin extension cost. Okay, we need to wait for it to compile. It has compiled. Now we just need to run it using the VS Code extension host. Converts string literal to a symbol. String lit to symbol. X equals string lit to symbol X. And now we've extended the language. We should also add it to the core library. Let's do that right now. Where is the recore? As you can see, this is in the VS Code plugin core folder. This is the one that will get published along with the extension once I update the version. After this video is over, I'll update it and you'll be able to use it yourselves. Okay. String lit to symbol, great. As you can see now that the error is gone now that I put it in. Okay. And yeah, this is basically it. We can also just fold it in right here, and this will create the pragma. I mean, the only thing we should do is maybe check that the string isn't empty. Match X. If it's empty, then don't put in the pragma. Otherwise, put it in. Oh, great. This is one way of doing it. Insert, instead of splice pragma, I just do it insert pragma. Pragma 1. And this will be pragma 2. And this will be pragma 3. And now you can very easily just generate the pragmas for the merge sort in the resulting output. We'll also make a version of merge sorts without these pragmas. Okay, let's do like this. Let me just get rid of this. We don't need these. Yeah. And now everything is perfect. Yeah, this is great. The only thing that I'd maybe like is to avoid copying the output on the first loop iteration. Okay, let's do it like this. In that case, if length input equals 1, then just copy it, return a copy of it. Otherwise, do all this. As you can see, you can put in an else statement like this in both Spiral and F#, and it will put everything inside of them. Okay, this is pretty good. I mean, if the array is empty, okay, right now it's a reference type, so it cannot be 0. But arrays that are, I meant to say it's a value type, so it cannot be 0. But if it is a reference type, and you are compiling this to something like .NET or Python, you can very easily have arrays with which have a type of 0. So in that case, I'd like to create a new object, which is why I am copying them here. I think in the future I'll just go into the into the base module in core HLS, and instead of having this be a value type, I'll probably make it a reference, something like this. I'll also have to make a constructor specifically for that in SIM. Probably first I create a new value and then create a reference specifically for it, but right now I don't care about it. Anyway, this should be the merge sort. Okay, now we have the merge sort and we can move on to testing. Now we need to get some utilities for testing. What we want to do is compare it to the C++ sorting function. And we also need to generate the data for it somehow. So we'll have to get the random number generator from here. And yes, it's a real pain in the ass to do this. We'll have to factor this out into its own module. Why am I using this byref? It should be out. No. Let's create a new module, something like random. And this should also be sort. We'll move it up here. We'll rename it. And there are other sorting algorithms besides merge sort, but for me merge sort is the easiest to implement, and it has O n log n complexity. On CPUs, quicksort is faster, but the problem with quicksort is that it requires random number generation. And the main reason why it's faster than the merge sort is because it does the sorting in place. But on an FPGA that probably doesn't matter. Especially for very small arrays like we are sorting right here. No. What should... Yeah, we need to copy this stuff here. Let's copy it here. Random device, master twister, uniform integer distribution. Yeah, okay, this makes sense. So, okay, this is how they are used. And I'll make this from 2. I generally use the naming scheme from near to and from to in order to differentiate the to from to. Oh, now once we make the distribution. Okay, is it making? Yeah, it's making the mason twister. Okay, we also we just move this. From to. And do it like this, so we can be sure that they are elements. Tags. I mean, it should also work like this, I think. But that's besides the point. Okay, we can make a distribution. uint distribution. This should be numbers, something like maybe a 32-bit integer. And yeah, I don't wish I had created the parser so it works similar to F#, but I thought of doing that several times, but every time it turned out to be too difficult. I mean, it would require some kicks in order to work like that, and I already had code written in this form, so I didn't want to bother. Okay, we can make the distribution. Oh, 0, 51. Wait, why is it passing the RNG into the distribution? Oh, I see. Oh, maybe we should be returning the RNG as well. What about her? Okay, let's nominal RNG empty from to range, okay. You should return energy. Let's do energy. This should be empty, and this should be macro. Why is this giving us a problem? Okay, let's also enroll this. RNG. Then we just need to do this. Okay, RNG list. Actually, we'll name it percent twister. I mean, this is not intended to be a serious random module. This is just so we can use the C++ random number generator in multiple places. Maybe if we are lucky, we'll be able to reuse this on the FPGA backend as well. Otherwise, we'll have to create our own random number generator. RNG. All right. We need a return type. And get int RNG. I32. Oh no, this is giving us trouble. We'll just use a macro to convert that, or maybe we have the conversion functions no problem. Okay. I mean, this is why creating a sort of function takes a long time, because we can't just type all this out and just assume that it is correct. We have to test it out, and this would be a lot faster if I wasn't targeting C++. In F# we'd already be done. Very disappointing that the HLS compiler doesn't have a library of things like sorting functions. I mean, just what are those people thinking? Nobody's going to use this when it's in this state. Oh, this. Okay, where is the? Okay, random make this. Okay, right. I need to put in maybe some kind of range. Okay, let's make it 0 to 51. We'll make this. We'll also use the init function to initialize random get int. Oh yeah, it wants the cards. Who cares? Let's make it like so. Now this is an array of integers. Let's make it something like 17 or 257. Now we have that kind of array here, and we need to compare it to the inbuilt one in the handranker. I mean, to the one that uses the this is the original. yeah, we need this sort in place. Can scorer sort. Okay. Inline hand scorer sort air. Okay, let's do this like so. Yeah, I think we can compare arrays to. Yeah, but I think that this actually, let's check things out a bit. Does it have something like, okay, it has a reduce, but it doesn't have the quality checker. Okay, where is it? In base, we have the equable and comparable. Once we implement those, we'll be able to compare arrays directly. Okay, let's do it like this. Instance oh no, what is missing? Dim L. Okay, no problem. We just need to iterate over the two arrays. Do we have something we can use for that? Does it have something like exists, or it doesn't seem like it? Okay, let's do a while loop. Loop while. Fun I less than length a. I mean, we don't need to check the both arrays because they're statically. They have static sizes and they have both the same size. Okay, fun I. This should be 0. Then yeah, we are in the SAM. We are in the static array module, so we don't need to open it here. We wouldn't even be able to do that. Okay, let's do if index AI equals index BI, then yeah, we just need to do this and nothing more. And yeah, we also need to increment the counter. And then oh, right. We need to break out of the loop if it isn't correct. Okay, let's do it like this. It should be true. Is equal. Both of these conditions have to be met. Yeah, we don't need to keep passing this on. Instead, we'll do it like so. Now we just need to take the first output, and then that should be it. Anyway, if you're writing this something like C++, you'd put it in a function and then do a return to break out of the loop. But Spiral is a bit different, and this distinction between ending the loop like this and returning from it, the C++ version might seem more convenient, but the Spiral in all functions, those are all like more like macros. Let's say they are something like that. So if you did something like a return here, because this isn't in a function, it would return from the nearby join point, which isn't here. So that would be a problem. Because it's written like this, the user has the option of putting the join point himself wherever he wishes. Okay, we'll also do a comparison. Comparable. And this should be eq, which is equal. There should be some helpers in the library, I think. Eq is, okay. Eq is eq. And we'll compare the elements. Yeah, now we have both of these. Now for arrays we can use the equality. Okay, we have this scan scorer in original x merge sort original. Alright, we need to pass in the sorting function. Okay, let's okay, and here that would just be the comp, and in the hand scorer sort, it's actually expecting the element to be a card, so we cannot use that, unfortunately. Instead, we'll have to put it here. In CPP stable sort. Fun dim l for all right, we don't need this. Instead, yeah, what we do need, oh yeah, now I realize the C++ sort returns requires a boolean. Okay, so we'll do it like this. Whatever, it can be a number. Who cares? No, wait, not this one. The element. Yeah, we also need to copy the array. Array is map ID array. In fact, well, let's just copy it like this. mean apply it like this. Then we'll fun AB be greater than A. And the B greater than A is not the same thing as A less than B, but A less than or equals than B. Okay, this should be good. Now we'll have to actually try running this after compiling it. Okay, let's do if x equals x, then 0 else 1. Okay. Okay, let's try compiling this, and we'll test it in Whitey's HLS. Yeah, whenever I'm programming in HLS, I wish I was doing web development instead. But I suppose if I was doing web development full time, I'd be wishing I was doing this instead. So I can never be happy as a person. I'm cursed to always be unsatisfied. Okay, now we're running this. Let's see what comes out. Some kind of error. I really hate how this ID gives me a stale report. I mean, this is one of the ways which tooling for FPGAs is poor. Okay, we'll just erase it. We'll erase all of these. Who cares? Maybe we forgot to import the random. Okay, let's where is it? Yeah, we need to import the random. And this should be not here. Okay, let's see. Main. Should be in here. Let's compile everything again. I mean, the port tooling is a bit of a consequence of what the audience for, what the customers for these kinds of tools are. They're very used to operating at a very low productivity level. On the bottommost level, you have something like the HDL programming languages, which are hardware description languages. Then above that, you have assembly. And above assembly, you have languages like C. Above them you have, but still in the same tier, maybe you have languages like C++. And above that you have dynamic languages like Python and JavaScript. And on the very last tier, you have languages like you have typed languages. On the middle of the tier are languages like C# and Java, which are getting better in recent years and adding more features from functional languages like pattern matching and virtual threads. And at the very top level, you have functional languages like F# and who knows, OCaml, and TypeScript. TypeScript also, I'd say, falls into a similar productivity category. And between the various categories, you have something like, okay, let's do a pause so I can illustrate what I mean. At the very bottom tier, you have these HDL languages, then you have assembly, as well as I include various internal representations, such as the .NET IL bytecode and the LLVM IR, which is an assembly language. Then you have something like C, and C is at the bottom of this tier. We'll make it something like this to indicate that it's let me send it to the back, so I can select this now, and then I put in something like C++ here, and between these two there's like a 10x productivity gap. And the same goes for something like here, 10x. And there are gradations within the tier. I'd say something like C is maybe like, I mean, it's a lot more productive than C because it actually has generic libraries. It has a sorting in its library. It has various data structures. In C, you'd have to implement all of those yourself. So it kind of depends. The productivity depends on your use case. If you need to make a program, write a program that requires a library, then C++ is a lot more productive than C, definitely something like 10x. But if you have to do everything from scratch, and then you don't need generic functionality, then C is like in the same tier as C++. But for the sake of simplicity, we'll assume that there's a 10x productivity gap between each of these tiers. Then you also have another tier over here. We'll do this, and then we'll say that something like Python, JS, Ruby, who knows, maybe Elixir. I don't know anything about Elixir. Out of the dynamic languages, Python and JS are the only ones I can really make a claim to be familiar with them. Then in the middle you have something like C# and Java, and I say that these are maybe just as productive as these two. It kind of depends. Compared to Python, let's compare something like C# and Python. They have features that are a bit orthogonal. Since C# has types, it will be a lot easier to, for a novice to understand what its libraries have, and it will also be a lot easier to refactor. But C# is also kind of complicated as a language because it requires you to put in the type annotations everywhere, and it's kind of driven by the IDE to get its full productivity. So it kind of has various flows. At the very top, you have languages like F# or Camel, and then I'd argue TypeScript to a lesser extent. Compared to F#, TypeScript has a more powerful type system, and it's kind of easier to make poor code. And it also has poorer syntax than F#. But it kind of falls into the very into the top of the top level range. So I'd say it's basically for a skilled practitioner in both languages. It would be, and assuming he enjoys using it, it would be just as productive as something like F#. And languages like F# have all the best practices, and it's very easy to use the libraries from an existing ecosystem, which in F# case is the .NET ecosystem. It can use all the libraries from C#, and I'd say the same would apply for something like Scala. Scala is better than Java and can use all the libraries like from the JVM ecosystem, from the JVM runtime that are running on the JVM runtime. And yes, this has something like a 10x gap. So, maybe going from VHDL to something like, okay, it's definitely a lot more productive to go from VHDL to something like C. But it's very rough to go from all the way at the bottom to something like in the very top tier, where the dynamic and statically typed modern languages with garbage collection reside. And in our case, since we cannot really reuse the C++ libraries except in the test bench, C++ is more on the C tier as far as FPGAs are concerned. So it's pretty rough. So that's a small digression into what I think where the various languages start. Like, I mean, imagine if you were told to program in Python and you really like F#. Yeah, I mean, you wouldn't like it, but compare that and HDL. It's like it cannot even be compared in terms of productivity. It will take you a full year, but it will take you something like a few days to do in Python. It's ridiculous. I mean, do Verilog and VHDL even have libraries for them? I'm not sure. So let's get back on track. We need to test the program out. Okay, it's complaining. It's complaining about what? Request for member v1 in tube0, which is non-class. Yeah. I think I understand what the problem is. I probably forgot to remove the card, or maybe not. Okay, let's see what the error actually says. On which line is it? On line 59. Yeah, I expected this to be the comparison. And yeah, it's trying to destructure a tuple. And this is a compiler error. Oh, where is it? Yeah, in the HLS CPP backend. Now, where is it? Where is the closure? Oh yeah, it's over here. Okay, if vars linked not equal to 1, then else. Actually, let's do it like this. Match vars with oh, it should be something like okay, let's just copy this here. Oops. Okay, like this. Then type t. I mean, yeah, it's a bit. Okay, let's do it like this. Then inside of here, we'll check the vars, check the length of vars. If vars length, then else yeah. Okay. I mean, the way I changed the closure compilation is a recent addition, and I cannot have the time to fully test it. You don't really need to worry about Spyrian being filled with bugs. The important stuff has been tested. Okay, let's compile this. Now it should at least run. Okay, while that's going on, let's go back to this a bit. I mean, I'd actually put C# and Java on the same tier. I mean, but it's kind of situational, because it depends. Where is it? It kind of depends. It depends on, you know, whether you are starting a project for the first time or whether you are trying to change a large existing project. If you're trying to, you know, maintain a large existing project, you want the C# and the Java type of languages. But if you are starting something new, then Python, JS and Ruby, these kinds of dynamic languages are easier to get started with. So, you know, maybe realistically they deserve to be on the same tier. But this upper tier, they have all the F#, for example, has all the advantages of Python and C#. So it deserves rightfully to be in a higher tier than C# and Java. The same goes for a camel. And yeah, okay, TypeScript, yeah, it deserves also to be in the same tier as F#, but you know, what I've seen is that a lot of beginners tend to, you know, it has a very powerful type system, but the beginners tend to abuse it. It kind of it's in the same thing with C++ templates and so on. Language has powerful features, and people that shouldn't be using it tend to use it. And that's kind of the thing that goes with it. I'd say the same goes for Scala. So yeah, I think maybe F# being a bit more lightweight compared to something like TypeScript and Scala works out in its favor. That's the reason why I modeled Spiral after F#. And I'm saying that in TypeScript the beginners tend to abuse the type system, but I actually think that many senior programmers tend to do that as well. Because, you know, the ideal way is to use a type system is to stick to first order logic, like maybe, which is like the majority of F#, if you don't use the higher rank types or reflection. But in TypeScript, you very often see very convoluted types that do type level computations similar to Spiral. So that really is something that acts against it. In Spiral, you have to do that kind of thing. Otherwise, there are programs that you couldn't possibly write. But in TypeScript, that kind of type system abuse is probably unnecessary. Let's go back to running this. Oh yeah, and the sorting failed. It returned a no zero value. And unfortunately we'll have to print it out. Okay, let's right, we need to go in here. Now we need to import it. IOStream. Now we need to iterate over it. Iter. std and l. Okay, then we'll print it out and see what comes out, whether any of the elements aren't sorted, for example. I mean, notice how we had to write a loop to compare the thing manually. In F# that would be automatic, and this is an important way that you know, higher level languages are productive, because they offer a lot of out of the box. Okay, 0 0 1 1 1 1 1 2 2 2 2 2 3 3 3 3 4 8 9. I think I saw a value at the bottom that was different from the other ones. Take a look at this here. It's probably the case that it isn't sorting the final value correctly. And you know, at first glance, this seems very correct to me, but it isn't, unfortunately. Mid from Oh, I think I get it. You know, what might be happening is that we are returning the wrong array. I mean, this switch always returns the nut. So maybe we need to switch these two around. Let's see whether that is let's see whether that was right. Oh, what is this 0 here? That's not right. Yeah, these are very weird errors, aren't they? And you know, once you get an error like this, you can only scratch your head. I mean, if you try testing these on small examples, it's very likely that you'd miss something like this. And you know, in that Reddit thread, I had a bunch of people telling me to implement my own sorting method. They're fucking insane. It takes a long time to make a correct one. And this is actually good progress. This one will only be fast because we have the original one in the C++ standard library to use for testing our own. Okay, what could possibly be wrong here? I'm not sure. I mean, was this change that we did even correct? I just did that on a beam. I hadn't really reasoned it out. Reasoned it out properly. Okay, this outer level, increasing the by +2 is fine, but times 2 is fine. Then in the middle loop, starting it off at by is fine. From near to okay, let me think about this thing. I once suggested that maybe doing this less than or equals would be right. So if we had an array or two or something like that. Okay, I have to pass. I cannot see what the error is. I mean, yeah. Now we have this kind of error. And now I have to think really hard about how to fix it, instead of writing the poker game. And this is something that I'll consider a serious minus for anybody wanting to use the HLS tools. Yeah, the community might as well not be there, since the only libraries are provided by the vendors. I mean, as well, if you look at in one of the threads, Reddit, FPGA, HLS, I mean, look at how many upvotes this post has. I mean, right now I'm trying to do a series on HLS, and everybody in community is telling newcomers to use different and much less productive tools. So that really doesn't inspire much confidence in using these things. When proper AI chips come out with concurrent cores that use message passing to talk to each other, I'll probably switch to that. But from a theoretical standpoint, FPGAs are really as fast as you can get parallelism today. So with AI chips, you'll be able to get the pipelining, but by the act of sending asynchronous messages between the cores. For example, something like let me do Excalibur. Where is it? Okay, it's here. For example, you have some kind of task which requires like Suppose the full task requires 10 seconds. You'll be able to break it down. Right now, the way the FPGAs work is by breaking the task into something like smaller pieces that they can pipeline. So, actually, I should have done it like this. Sorry, let's do it like this. You can kind of do it like this, and then you can keep the pipeline saturated. Like when this task finishes, you know, it will automatically send it to the next one, and to the next one, and to the next one. But this kind of concurrency, you can easily see how it could be implemented using asynchronous agents within the same chip. If you had an AI chip which executes something like for 2 seconds, and then 2 seconds, my god, 2 seconds, 2 seconds, let's make this 8 seconds. I can be asked to type 2.5 everywhere. So yeah, you can get this kind of pipelining parallelisms using asynchronous agents, asynchronous cores using message passing. And you know, compared to an FPGA, this would be a lot easier to program. And you know, these cores would have a lot higher clock frequencies than FPGAs. They have something like 10x the clock frequency. FPGAs tend to be clocked like at something like a few hundred megahertz, but CPU cores tend to be something like a few gigahertz. The modern ones are something like 4 gigahertz. And the FPGA we have now is something like, on the F1 instance, is something like 250 megahertz. So there's like a 10x gap between the clock frequencies these cores can accomplish and FPGAs. And they'd be a lot easier to program. So there's something to look forward to in the future. But right now we simply don't have any choice but to use these. Okay, I don't know why things are like this. I mean, I can't imagine any reason why this 0 would be here, because I don't think the loop boundaries are wrong. Right now I'm even considering testing this out in F#. Let me think. Okay, suppose the input array is length of 2, then it would need to run this iteration once, and it will, flip the switch over here. The switch starts off as true, so after that iteration it will be none here, and we do want to get the output array in that case. So yeah, we need to flip it here. Let's just do it like this. And yeah, our change that we made is correct. Now the only question is, why is that middle value in there? Okay, not much we can do. I mean, there are kinds of situations where you cannot really reason out what the problem is. So in that case, you need to do sanity checking, and a lot of it. I want to see whether the other array is correct as well. Wait, just a second. We were previously, yeah, X is the merge sort, and yeah, okay. What's this? This is really weird. I mean, this wasn't what was printed here last time. We're having some kind of memory error. That's the only thing that I can think of. Like once we started printing this one, the results change completely. This cannot possibly be true. Okay, there's something deeper about this than I thought. Okay, when I uncomment this out, I get the same results as before, but you know, I'll be running into some kind of weird undefined behavior. I mean, this kind of error isn't really normal. It isn't something that I get if I missed a bound here. It's more like some kind of memory corruption, and it's very unusual to get that kind of thing here. I am very confused. But you know, it's not like I'm a C++ expert. Okay, this is the original array. Yeah, it's not very sorted. This one is definitely sorted. Okay, let's put the print statements in here. What is going on? I have no idea. Cout. From near to we'll put something like a statement here and print out Oh yeah, we should also be printing out the midpoint. Mid. And of course, I probably, yeah. I mean, these kind of errors happen. I don't have any ID assistance inside the macros. Yeah, I mean, these values are exactly what I expected they would be. Okay, now we have the second loop. Wait, just a second. Oh yeah, the final iteration is missing here. There should be one that goes to 256 and with the midpoint being 257 and the near to the max. Okay, right, I see what the problem is in that case. Wait, let's think about this for a bit more. Yeah, we don't. Yeah, here it cuts off at 2.6, but we need to have it go one extra iteration either way. You know, in the final iteration. So putting something like less than equals would not really do anything to fix this kind of bug. Anyway, for now, let's just let's just test this out. The reason why we were getting memory corruption is because in the final iteration it was going past the end of the array. And you know, this kind of issue only happens in the very last loop. So when we had the NOT switch here, when we had the switch here, that's why we didn't. That's why we weren't getting that problem then, but now we are. Okay, so now this min should take care of the end of the array. Let's just test it out. And you know, we cannot really take this for granted. We are going to have to test many different sizes for many different iterations to make sure that they are right. The compilation here really takes a while compared to something like F#. In F# we just, you know, copy paste this into the REPL and then we'd be done. Oh yeah, it's done with the 0 errors. It seems like we fixed it. And it's showing us a stale report with the error. Alright, no. It's we just still have the count statements, the print statements inside here. We can get rid of those. I mean, it should be right, but who knows? Oh, we need to fold over it. We need to check that whether it works for any kind of size. Okay, let's do it like this. Inol try size for all dim. Okay, let's make some kind of nominal size x size dim yeah, I mean, doing it like this is definitely very annoying, but I mean, we can just you know, we don't even need the nominal. We can just pass in the literal like this, and then we're going to have to iterate over various different sizes. No, we need the loop for from, let's say, from 0. No, we start from 1. From 1 phone I yeah, and we cannot even use this kind of loop. We need a tail recursive inlining loop. Okay, let's do it like this. If I less than 2.6, then something else. Okay, then real try size we can pass in anything in here, and otherwise loop 1. Okay, let's do this. Something like true, false. Okay, then inner b. Okay, where is it? B end loop I plus 1, else true. And then if then I32. No, what's the problem? What? I32. And once we try running this will generate a lot of code. But we need to do that because we are using static arrays. It's easier for us to generate a lot of code than, you know, do something else. I wonder how long this will take to compile. A shitload of time, probably. I wonder if the server will crash. It is compiling, I hope. Print static. Oh, just a second. Okay, I'm going to abort the server and start from the beginning. And then let's build the file. Oh, wow, interesting that it gets slower as the compilation goes on. I didn't know this would be the case. I didn't expect it. I wonder why it's getting slower. Okay, let me pause. Okay, let's abort. We'll do it for something like 70 iterations. So why it's getting slower when as the compilation goes on, that's something for me to investigate. Yeah, I don't think it's because of hash consing. Okay, let me pause and I'll... Okay, we're back. And I see something right now. I didn't expect this. As you can see, we have a very deeply nested if statement. Okay. And I also messed up because this should have a loop in it somewhere. Okay, let's do it like this, something like let. You should have a join point and then make the stuff. Instead, now what I want to do is a bunch of iter from 0 near to something like 100 or maybe even 1000. These aren't large values. Then we can put this here. Loop. Okay, we'll do something like, okay, we'll pass in a state which is true. Yes, and true. Why is this giving us a problem? Boom. Alright, right. Does this have a state? It has an iteration count. Alright, maybe it should be like this then. I32. And this is now the index, and this is the state. We can do it. We can also do it like this, since it is an operator. And I think once we use the join points, it should get a bit faster. It shouldn't be so deeply nested. Let's compile it. Oh, it already finished, it seems. Wait, why is it the same everywhere? That shouldn't be the case. Oh, right. Oh, I still have this here. Damn. Oh, let's try it again. Oh, now with the join points it is much faster, even though the amount of produced code is the same. I'm guessing because it doesn't have so much deeply nested inside the if statements. I mean, this is something to keep in mind if you're going to use a spiral. Oh, yeah, this is a lot of code. Okay, let's compile it. This compiler will take a while. Okay, I'll pause here and then come back in a few minutes. Okay, I'm back, and it says that it's done with the 0 errors. Then in that case, why are there things being printed here? Okay, this is the original array, this is the sorted array, and this is who the hell knows what. I mean, it has 6 elements. 1, 2, 3, 4, 5, 6. And our method isn't sorting it properly, it seems. Yeah, this should be reversed. Or maybe, yeah, it's true. Okay. Okay, we need to put in a print statement because it's really annoying right now. Oh, that takes care of that. Now we need to come to an understanding why it isn't sorting our own array. Like in this case, it doesn't seem like it's sorting it at all. Okay, 3, 16, 27, 36, 41. That's okay. But this 13, why isn't it being sorted? The problem seems to be in this position. Okay, let's... Okay, it does seem to be having errors from... below the 6, only on the 6th. So that's what we'll be investigating. Let's just make it 1 for now. No. Okay, I'll put them in. We want to put one outside. I'll compile it. This was done quickly. Let's run it again. Oh, we don't have any errors on this single example. Instead, we'll need okay, let's do it. Let's do something like error, and then we'll also make it 1,000 iterations. Okay, here are the errors. 16, 27, 36, 41, 13. The C++ sort method does a perfect job. Around does a shit job. Okay, these should be sorted. Then 0 to 4. And you can see what the problem is. We have 0 to 4, but we don't have 4, 6, 6. Okay, this is a bit easier to understand now. The problem is that I'm getting this conditional wrong. I thought that it made sense, but it doesn't. And that it doesn't is something I got a clue right here. The way I originally thought about it, I thought that maybe it would be possible to, you know, do this. No, actually, I meant that to do. Sorry. Okay, we're going to do this in a way that's easier to understand. Let's do this from. Yeah, this way is perfect. And then we'll be calculating the mid. Okay, the mid is just the from plus by. And we need to also, you know, take the mean. Length in. We'll do it like this. In fact, let's make this add by x plus by length in add by from inline near to add by mid. Okay, yeah, I mean this is correct, but we can do it will be more efficient if we multiplied instead. Okay, let's do by times I add by to from. Okay, now it's better. Honestly, this is a good lesson for me too, because I didn't think about the way I'm doing looping so deeply. I mean, there's no reason I couldn't pass in from like this, but I didn't. Yeah, and now instead of passing in the by into this, we need to pass in a 0, and that will take care of everything. Well, let's give it a try again. Oh, it finished without error. Okay. Oh, now let's do it for all of them. We'll start this off at 1 once more. Then let's go up to 100 or something. Okay. This can be like so. Oh, now let's compile it. Oh, and if you see how much code there is, it isn't actually, the compilation isn't even that slow. It was much slower in the old Spiral version. The C++ compiler should be a lot slower. Let's run it. And if you look at the time, it's 5 hours and 7 minutes. Let's pause here. And actually it didn't take that long to compile. And the simulation is done with 0 errors. Okay, great. Now we can be sure that our sorting algorithm is implemented correctly. As you can see, it's super easy to fuck up. And if you try a few small examples, you might get a fool that it's doing the right thing. Now, okay, if we want to, for example, inline all the loops, we just pass in the inline pragmas everywhere. Inline, inline, inline. And then, okay, let's restrict the compilation for a bit. If you look at for pragmas, pragma, they aren't anywhere, it seems, because we aren't calling that function. pragma. Why is this happening? It's not inserting them for some reason. Oh, this is very weird. It's not executing this at all. Let me pause. Alright, because, you know, we have this thing here. Okay, let's start it off at 2. Pragma, yeah. We have this HLS inline pragma. The only thing I'm wondering is whether this semicolon will cause problems. Let's give it a try. Can I get rid of this? Okay, never mind. Okay, with this we are done with the merge sort. Okay, before we end the video here, I just wanted to show something out. In the previous video, I said that C++ is too inexpressive as a language for us to, you know, pass in pragmas through as an argument, but it doesn't seem like that was right. This is a talk that I found on YouTube on SYCL, which is like a library for programming heterogeneous computing architectures. It's based off OpenCL. And if you look at here, they have this SYCL extension Xilinx pipeline. And this would this would do the same thing as adding the HLS pipeline pragma. And you can do this for various kinds of pragmas as well. There are other examples in this talk. So I just wanted to clear the situation between us. I don't want to mislead anyone into thinking that it's absolutely impossible in C++. To admit, I don't understand what kind of mechanism they are using to do this. Maybe they are generating the HLS code. I don't know. I am not privy to the secrets of the C++ compiler pipeline. Okay, now with that, let's end the video.